Hello everyone, welcome back to my channel. And today is another episode of 100 days of DevOps. So far we've had five phases. We've had the fundamentals, we've had containerization, we've had cloud, migration to cloud, we've had infrastructure as code, we've had one other one. And we've covered a lot of things. We've covered Docker, we've covered Git, we've covered um, Jenkins, we've covered Azure, we've covered Terraform, and we recently wrapped up the session on Ansible. If you're coming across this channel for the first time, what we're trying to do is we're trying to cover DevOps in 100 days, covering the most important and critical parts of DevOps and the things that we need to know in order to kickstart our journey in DevOps. And so far, like I said, we've covered what we've covered, and we wrapped up the Ansible session in the previous video, which is yesterday. And that session concluded the intermediate part of DevOps. So today we are going to be going into the advanced part of now we are in the advanced part. Now we are going into the advanced part of DevOps. And what that means is that gradually we are coming to the end of our series. And I don't know about you, but I'm really excited. If you've made it so far with this journey with me, I want to really take the time to appreciate you. And you guys are, you know, MVPs, and thanks for all the support, the comments, and all of that. So we are going into the juicy part of this series, and it's a part that every DevOps engineer is always looking forward to. Every DevOps engineer, you see, and every DevOps engineer, they want to know about this phase. They are always concerned and everything. It's one of the most important parts of DevOps after CI/CD. And what we are going to in this phase over the next couple of days is container orchestration and GitOps. Remember, in our CI/CD phase, we looked at only the CI part, and I mentioned there that we are going to cover the CD phase when we do or when we are done with container orchestration. As the case may be, I'm joining these two together in a single phase, and this might be one of the lengthiest parts of the series, and that is because container orchestration is not something that one can cover in a short while. You can't fully cover container orchestration even in 10 days or 15 days because there's just a whole lot to actually cover. That's why it's in the advanced phase. It's an advanced concept that you need to take your time with it to actually get grasp. And what I'm going to do is that I'm going to try and take it little by little so that we can understand. Because if we can get the good foundation in container orchestration, I feel like it's going to turn out to be one of the most easiest things that we will ever work with. So in this stage, we'll work with Kubernetes and different parts of Kubernetes and all of that. But before we go into that, let's go into what we have for today. I think for the next today and maybe the next series, I'll take my time to explain things. We will not touch the terminal, we will not do anything practical. We will just focus on theory in for the next two sessions. And the reason why I'm doing that is because I want to take my time to the best of my knowledge to see how I can explain and how I can present it in a way that anybody watching this, once you watch this video, you have no issues whatsoever with container orchestration or Kubernetes as you want to call it. I hope you know that Kubernetes is not container orchestration. Container orchestration is the concept, Kubernetes is the tool, right? And Kubernetes is not the only container orchestration tool. There are several others, which we are going to get into before the end of this session. So without me wasting much of your time, let's go straight to the business of today. So container orchestration, I will try to break it down, and this contains two words. The first is container, and the second is orchestration. I will start with containers, and we've had our session on container. If you've watched that phase, by now containers should not be a new thing to you actually. But as a refresher, I will just go through it, and um, I would I always like I always do in every phase. I always want to help everybody understand why. The first thing is when you see a new tool, when you see a new concept, the first question you want to ask yourself is why? Why is this concept developed? Why is this concept, brought about in the first place? Then you now go to the what. What has this concept come to achieve? What what can this concept actually do to make things better or to make your life better? Then after you now move for right after you've grasped the why and the what, then you now go to understand how. How does this work? How does this affect the bigger picture? So that is what we have been doing since the beginning of this series. We understand the why, we move to the what, and then we talk about the how. If you check all my videos, we have followed that pattern since the very first video of this series, and it is good that way so that we have a very solid foundation of what we are doing. So why container orchestration? So to I'll take us back memory lane. And first of all, why containers in the first place, right? Because I said container orchestration is two word, container and orchestration. So why containers? Now, just like I explained during the containerization session, I said containers were brought about. Before then, what we had was a bare metal, right? A single server. An application is hosted on this server. One server to one application, right? That was what I said. One server to one application. You host an application on this server. So imagine this server has like a large servers are usually are like supercomputers, right? They have very large resource capacities. They can have thousands of gigs or thousands of whatever. And imagine you are hosting just one application on a single server. What the challenge brought was resource wastage, right? Resource wastage. So from bare metal, that was what brought about virtualization. So let me think I need to write it down so that we get the bigger picture. So start with bare metal, bare metal. Then we move to virtualization, where you install the hypervisor on the bare metal, and then you are able to now set up virtual machines on the hypervisor and then run your apps. So it's not like you have a hypervisor and then you now have virtual machines on the hypervisor and then you now put your app on top of it, right? But now there was still a challenge. It was this was something that was very heavy. It was heavy one to implement, and then secondly, the the cliche phrase of "it works on my laptop." The developer will work on it. It will work on developer's laptop. When developer pushes to production, it breaks, and come back to developer, and developer says, "But it worked on my laptop." So to remove the phrase of "it works on my laptop," that was where containerization containerization came into play. So what containerization does is that containerization is a lightweight package of an application. So you package the application, you package the dependencies, you package the libraries, everything that will make the application work. You package it into an image so that regardless of your environment, regardless of your operating system, all you need to do is get a copy of that image and deploy it, and that image turns to a container, and then it works across all platforms, right? And then that's I'm just trying to rush through and quickly get onto everything I want to do. If you want a very very good explanation, if you can watch the containerization phase of this journey, I spent a whole lot of time. explaining all of this, but this is I'm just trying to rush through everything. So now you can deploy containers anywhere you want. It's lightweight. You can do whatever you want to do. One application, you know, looks like everything is, going fine. However, now there's another challenge. The challenge now is that the container platform we use, the most popular container platform is Docker, right? Now you install Docker on one virtual machine. Let me, this is the virtual machine, and you install Docker. Let me draw it. So Docker is installed on a virtual machine, and then from with Docker, you can now do Docker pull to pull an image and Docker run to run an image. Okay, you have your application running, and everything seems fine. Everything seems fine, and then all of a sudden there's a spike. Maybe when the application started, you had about maybe 1,000 users, and it was looking fine, and also and everything is okay. Now suddenly the application starts growing, and then you discover that you're not serving one 10,000 users, right? You might think, okay, what you want to do is you just deploy another application, like deploy another container of that same application. But now, when you deploy another container of that same application, remember that they will have different IP addresses. Container one and container two will not have the same IP address, right? Now, for users, and again, you cannot give some particular users maybe this IP address, and then you give another user this particular IP address. It doesn't make sense, right? It doesn't make sense. So for this to actually work, you now need a load balancer, because the load balancer is what distributes traffic among to different backend servers of that are serving the same application. But Docker does not need provision for that. That's the first thing. Load balancing is very, very difficult to implement with Docker. That's number one. Secondly, because containers are lightweight, I mentioned it that they are ephemeral in nature. What I mean by ephemeral in nature is that they can they can crash at any time, right? They can crash at any time. Okay, let me highlight the issues. The first one, load balancing, and okay, no, okay, let me say load balancing. No, scaling, because yes, when your traffic spikes and then you want to add more, it's difficult. So now let's go back to what we're talking about. Because containers are ephemeral, they can they can be easily killed. Like containers can die easily. So what happens if your container, if for example, maybe because of the increase in traffic and all of that, and some one or two issues, then maybe there might be like a power issue or anything, your container dies. How do you get your container up and running? That's another question. So that's what brings us to self-healing. This is another challenge when it comes to um, um, Docker, right? Now, how do these containers even talk to each other, right? How do these containers talk to each other? Networking. Yes, we have Docker networking and all of that, but Docker does not really offer that advanced form of networking when it comes to containers talking to each other. That is the third challenge. The fourth challenge, how do you apply updates without downtime, right? How do you apply updates to your container without having a downtime in like with your container? So these are these are like I could give like a very very long list of issues that can happen with just running your container, right? These are just four out of a whole lot. And okay, how do you automate all of these things? Because there is no automation. Even if you want to, even if you want to deploy more containers of an application, you have to manually go and do Docker run, and then you keep adding, and then you keep adding, or you keep adding, and all of that. So there is no much automation when it comes to containers alone, right? And this is what container orchestration has actually come to solve. This is what container orchestration, these problems or these challenges is what container orchestration has come to solve. Issues like self-healing, like auto-scaling, like networking, automatic deployment, load balancing. These are things that container orchestration actually came to actually solve. So now that we understand what container is, now that we understand what the um, challenges of just running a container, then we can move to orchestration. Now, in a small setting, if you want, maybe if you're just for testing phase, yes, you can have a container, one container. If you're working with just one container, then you might not really have an issue and all of that. But if you want an enterprise level, you have to look into the container orchestration part. So now we understand containers to an extent, right? And now let's move to orchestration. So what exactly is orchestration? When you hear of orchestration, the first thing that comes to your mind is orchestra. And a lot of us, if not all of us, we know what an orchestra is. Orchestra is like a group of musicians, like a group of instrumentalists coming together. They play different instruments and then they make music out of it, right? So there are different areas, there are different aspects of an orchestra. There's the people that plays the piano, and people that plays the drum, the people that plays the violin. Now let's imagine that those piano, drums, violins are containers. If you've watched an orchestra before, nobody plays anything except the conductor asks them to play it. There will always be a conductor. There will always be a conductor. If there is no conductor, everybody will just be playing as they like. But it is the conductor that tells which one goes first, the progression, who goes before who, how many beats are you supposed to like. The conductor is the one that controls everything, and that is what orchestration is all about. Orchestration helps to control everything. Orchestration helps to automatically manage multiple containers so that they work together as one unit or as one system. In a nutshell, in simple terms, orchestration automatically manages multiple containers so that they work together as one system, right? And how does it do that? How does orchestration do that? So it's not just running containers. Orchestration manages their entire life cycle from when they are deployed to if any issues, their networking and all of that. So let's look at starting and stopping of containers. Okay, so now instead of manually doing starting and then stopping a container, once you deploy a container, orchestration is responsible for starting and stopping containers. Let me write this: container life cycle. So it manages the entire life cycle of that container. If the container needs to restart, if the container needs to be stopped and all of that, it manages it. That is part of the things that orchestration does to containers. Secondly, let's look at scaling. Basically, when you're setting up an orchestration environment, right? It's a robust environment. It's an enterprise environment. So now, once your user, like I gave the example of when you have users from 1,000 to 10,000, if your users increase or if there is a spike, the orchestrator automatically creates more containers. It creates more containers, and while it's creating more containers, there's already an automatic, like there's already a predefined load balancing system that balances the load across all the new containers that is created. So you don't have to start configuring load balancing and everything. Yes, the containers that was spin up will have different IP addresses, right? But because of the the automatic load balancing nature of the container orchestration platform, you don't even need to bother about the underlying IP, except if you want to troubleshoot a pod from, you know, from the a single container from the entire pod, right? When we maybe tomorrow or the next, we are going to look at pod and all of that. Sha. So if you want to troubleshoot maybe like a single container, then you can now go into the container's IP and start doing what you want to do. But on a high level, despite each container having different IP addresses, there's an automatic load balancing in front of it, which is called a service. So it is that service. Service has like automatic load balancing that distributes traffic within the cluster. So that is taken care of. So in terms of scaling, and the good thing is that it can scale up, it can scale down. If your traffic goes up, it can add more containers to balance the load. If the traffic goes down, it can reduce those containers, and you don't even have to do anything manually. You just have to pre-configure some things, and then it takes care of everything. Thirdly, is the issue of failures, which pertains to self-healing. The orchestrator will automatically restart failed containers. If it cannot restart the failed containers, it will replace that container, by itself without you having to do anything. So container orchestration or the orchestration platform is responsible for, you know, restarting failed container. So you don't have to worry about a crashed container and everything. It will do that automatically. It will restart it. And in fact, when you are going through your cluster, you can even see the number of times that a particular application has been restarted or a particular container has been restarted. You will see it. Then you can now look and check what is wrong with it and all of that. So also networking, networking and communication. So now there's something called service discovery when it comes to container orchestration. So discovery is how containers discover themselves within the cluster. You don't have to manually set any of these. It will handle it automatically. It will handle it automatically. So this pod can see this pod, or this container can see this container, and they can communicate. And then the application is working fine without you even having to know what is even happening under the hood. However, in this phase, of course, we always um, try to explain what happens under the hood so that when it comes to troubleshooting, you know what to do because there is no tool, there's no platform that is 100%, um, automatic or that is 100%, how do I put it now? At some point or the other, you would need to do one or two troubleshooting. And if you don't understand how things work under the hood, if you don't understand how things connect to each other, you will be lost most of the time. But to an outsider, they don't even have to bother about some of these things because the platform takes care of everything. Now, lastly, when we come to updates are done automatically without you would not even notice a downtime. You will not notice a downtime when it comes to update because it does that automatically. New versions of the application can be deployed gradually. Old versions will be removed gradually so that there is no downtime. The customers might not even notice that anything is even going on, and it will do it gradually till the new version completely replaces the old version. That is how it um does it, right? So basically, that is like few of the things that the orchestration has come to do. Like I said, the orchestration platform is like the conductor, and all your containers are like the musicians in the orchestra. So the conductor manages everything, every part of the orchestra, or every part of the orchestration is managed by the conductor. And then, the entire life cycle and all of that. I don't know if everything I've been saying in the past, 5 to 10 minutes has actually made sense. But if it has, I really hope that you've gotten it. So we've been able to talk about containers. We started from bare metal virtualization containers, and we looked at the limitations of containers, right? And then we said those limitations is what container orchestration platforms have come to actually um, solve. Okay, so now that we know what container orchestration is, the last thing we are going to do for this particular session is we are going to look at the container orchestration platforms. And we have a couple of them. I'm just going to list them because I think hardly will you see just a single tool that solves a particular issue. There will always be multiple tools that solves one particular issue, and then the choice is yours to actually make on which one you want to use. So I'm just going to list what we have, the platforms that we have. Let me move this here so there's space. Okay, and then move Docker here. Okay, let me insert again. So the first is Docker Swarm. Docker Swarm is a container orchestration platform. There is Kubernetes, there is Mesos, there is OpenShift, and and the like. I think I am aware of these four. I don't know if there are more. If there are more, you can call my attention to it or drop it in the comments. But I'm aware of these four. Now we know that Docker is like the number one container platform. So if Docker has Docker Swarm, why don't we go for Docker Swarm? Now, Docker Swarm is good, but Docker Swarm does not have the advanced features that we need for enterprise level. Because whatever we are doing it in a bid to get ourselves prepared for enterprise, great stuff. So Docker Swarm is not advanced enough for enterprise level stuff, for enterprise level container orchestration. It's not just advanced enough. Now, if we look at Mesos, Mesos is is too advanced, right? It's too advanced. It's complex to set up and complex to use. I've not used it before. I've not used Docker Swarm before, but during my research for this particular video, I got to understand one or two things about them. So now we have Docker Swarm, which is not advanced enough, and then we have Mesos on the other hand, which is you know too complex to set up. That brings us to the champion of today, which is Kubernetes, right? So, which is Kubernetes. Kubernetes is right now the most recognized container orchestration platform. It was developed by Google as one of their projects, and then I think CNCF started um, are the ones in charge of this particular project. They manage, everything Kubernetes and all of that. Into we're not going to concern ourselves with that. So during the course um of this series, we're going to be working with Kubernetes. OpenShift, on the other hand, is in terms of enterprise level. Personally, I feel OpenShift is a step above Kubernetes. So I'm putting it out there. You guys watch out for OpenShift because I've worked with Kubernetes, and even in my current organization, what we work with is OpenShift. So the reason why OpenShift seems like um an advanced or a layer on top of the Kubernetes is because OpenShift underneath the hood is Kubernetes. OpenShift is developed by Red Hat. Red Hat. So what Red Hat did was that Red Hat, since Kubernetes is an open source platform, it's actually open source. So Red Hat took Kubernetes and then build an advanced feature, add-on features on top of Kubernetes, and then you can do so many um, things with OpenShift. Maybe before the end, I might just maybe show us how OpenShift works. Maybe I'll dedicate one video to looking at OpenShift, maybe or maybe not. Maybe I might have to just do a different series for OpenShift. But for this particular phase of our journey, we're going to focus on Kubernetes. And we're going to end this video um, here at this point. In the next video, we're going to look at Kubernetes and everything that Kubernetes entails. So if you've liked the video so far, if you've understood the video so far, so please do well to give a thumbs up. Also subscribe to the channel. If there are any questions regarding everything that I've said today, please feel free to drop your questions in the comment section. I'll be there to answer whatever questions, whatever clarifications that you would actually need. So I hope I've been able to do justification to why container orchestration, came into play. So I hope we all understand the why of container orchestration, right? And then we also understand what. I think I've covered why and I've covered what. Why there's need for container orchestration and what container orchestration does or what container orchestration offers us. So in the next video, we'll start with understanding Kubernetes and but why Kubernetes? Well, since we already understand why container orchestration, I'm not sure there's a need to do another why. So we're going to do what Kubernetes. We're going to look into what Kubernetes is. We're going to look into Kubernetes architecture, and then we'll see what we can make from the next section. So I'll see you on the next video. Enjoy the rest of your day. Cheers.